So hello and welcome everyone. My name is Jay Dalsaniya and in this video we are going to solve the question string subsequence. So this is the problem of the day for 30th of May, right? So this question is quite easy if you know a strategy to solve it, okay? And if you are not aware about this strategy on how to approach this kind of questions, don't worry. In this video you'll get an idea basically how to approach this question from brute force till the optimal approach. Okay, so without any delay, let's start the video. So the name of the question is string subsequence. The difficulty level has been marked as medium, and we can see the submission is around 14,000 submissions, and the accuracy is 57%. Okay, quite a good accuracy for all of you who have solved it, right? So in this question, basically, you will be given two strings s1 and s2. You have to count all the subsequences of the string s1 that are equal to the string s2. Okay, so you'll be given two strings s1 and s2. So let's take this example and let's try to understand what basically the question is trying to say. So let's see a test case over here. So let's say we have string s1 and we have string s2. So string s1 is geeks for geeks, and we have another string that is what it is. Let's see, that is gks. Okay, so what you have to do, the question is saying that find out all the subsequences of s1 that are equal to s2. So if I point out one subsequence, I'll select this g, I'll select this k, I'll select this s. So gks, so this is one of the sequence that I found. So now instead of selecting this s, what I will do, I'll select the last one, I'll select this s. So this is one more subsequence that I got, gks, right? Now what I can do, instead of selecting this k, I will select the last k over here. Okay, so I have got one more string that is gk, and I'll select this s, so it will be gk and s. Okay, now I started with the selection of the first g, right? So what I can do, I can go with the second g. Okay, so this is the second g. I will select this g and I select k and s. Okay, so in total you can observe I got four basically subsequences of s1 that are completely equal to s2, right? So that is what the question is trying to say. You have to find out all the subsequences of s1 that are equal to s2, right? And there is a note mentioned that the answer can be very long, so you have to apply modulo 10 to the power 9 plus 7 to the answer. Okay, fine. So we'll keep that into consideration whenever we write the code, but that will not impact our logic. Obviously, it is just some mathematical thing that's required to bring the answer in integer range. So let's understand like how we can approach this question. Okay, so the question is pretty easy if you start with the brute force manner. Okay, and try to guess what can be the brute force manner. Okay, because uh, for many questions the approach will directly start when you think about brute force approach. Okay, and then you can basically keep on optimizing it and you will get an optimal approach in that manner. Okay, so let's discuss the brute force approach that can be applied over here. Okay, so I will take a different example of strings over here. I'll say s1 equals to, let's say, ACABB, and I will say s2 equals to AB. I have taken this example, and throughout this explanation about brute force and other approaches, I'll go with this example. Okay, so in this string s1 and s2, if you want to find out all the so-called subsequences of s1 that are equal to s2, the answer will be what? Let's try to solve the answer. So what I can do, I can find out all the subsequences of s1. I can find out all the subsequences and find out which subsequence is equivalent to s2. Okay, so there can be so many subsequences, right? So for this, if I try to solve this question, what I will get as my answer, I'll select this a. Okay, I'll select this a, I'll select this b, so I got ab. Then I will not select this b, but I'll select the second b. Okay, I'll go with the second b, so I'll get one more string, that is ab. Now I will not go with this first a. Instead, what I will do, I will go with this a and then this b, so I'll get one more ab, and then again I'll not select this one, I'll select this b, so I'll get ab. So for this test case, the output comes out to be what? It comes out to be 4. Okay, so this test case gives us the output as 4. Okay, fine. Now how to find out all the subsequences and how to basically approach in that manner. So what you can think about here is that, let's say I have two strings, right? I have s1 and s2. I'll just draw the basic idea what we can do. I have string s1, okay, and let's say the length of this string s1 is n. I repeat, the length of the string s1 is n, and the length of the string s2 is what? Let's say it is m. Okay, I'll write down n mm. Okay, so s1 has length of n, and s2 as length of m. Okay, so what I can do, I can compare the last character of s1 and s2. I will go with the last character, you can go with the first character as well. So I'll compare the last character of s1 and s2. Okay, now what are the possibilities that you can find whenever you do the comparison, right? So basically there will be two possibilities, right? What are those two possibilities? Let's say s1, the last character will be s of n minus 1, right? Will be equivalent to what? s2 last character. Okay, this is one of the possibility, both the characters are same. And the other possibility that you can find is that the characters does not match. The characters will not match. S1 last character n minus 1 is not equivalent to what? The last character of S2 m minus 1. Okay, length is n, length is m. N minus 1 is the index of the last character, m minus 1 is the index of the last character of S2. Now here, if basically these two characters are matching, then what we can do? We are trying to find out all the subsequences of S1. If we are trying to find out all the subsequences, basically for a particular character, for ith character, what approach should I follow? I can either select that ith character or I can discard that ith character. So if I'm selecting the ith character, basically that means I'm matching both this character and I'm just looking on this much of part of the string, and I'm trying to find out what is the count of subsequences that match between them. And if I'm discarding it, that means I will keep the entire string as it is and I will look on this much of part and I will see how many basically subsequences are there that are matching over here. So that's the basic thing that I will be following. And this can be implemented using recursion, and recursion is the best way to implement such kind of algorithm, right? Such kind of solutions. So I have two possibilities. Either I can go with the last character of S1, I will select it and I will move forward with the remaining characters. So what I will do, I will select S1, I will select the last character. So how many characters will be remaining? N minus 1, and the last character has been selected. Okay, basically it has been compared and it has been found that they are matching. So I'll move with the other part of the string and I will select the last character and I'll discard the last character. Now this is another sub problem. I have two string s1 and s2. Length is n1, n minus 1, length is m minus 1. Now find out all the subsequences of s1 that are equal to s2. So this can be a recursive call, right? And the other thing that I can follow over here is that I can find out the possibilities. I can find out the other possibilities. What I can do, I will select s1 and what I will do, I will basically discard the matching character. Although I know the last character is matching, right? Last character is matching, but then also I discard it. So that means I will keep the other string, that is s2, completely, right? So it will still contain m characters. And now what I will do for this sub problem, what does this sub problem say? It says find out all the subsequences of s1 which is of length n minus 1 and find out basically how many subsequences are matching over here. So these are the two recursive calls that I will be doing for the last character matching. Now if the last character is not matching, then what you should do? If they are not matching, then basically you need to discard the last character and you need to look for the rest of the string, right? So that means if the last character is not matching, okay, s1, so I'll have n minus 1 characters because the last character was found to be different. And what does it mean over here? S2, it means that all the characters are still yet to be found, inside s1, are still yet to be found on inside s1, right? So that is what it means. So this is entire recursion. So I will have a problem of n and m. I will check the last character, they are matching. Yes, then I will call for the other sub problem. I will discard the last character if they are matching. Then I look for this sub problem, and I will also have a look at this sub problem because I want to find out all the subsequences and check how many subsequences are matching. So this is one of the way of doing the subsequence matching, right? And what will be the base condition for this recursive function? Okay, so this is the logic of our recursion. Okay, these are function calls. Don't worry if you are not able to understand for now, because I will give you a dry run with the example, so it will make much sense afterwards. Okay, and this is a basic thing that everyone should know. If you are good at recursion, you should be able to find out all the subsequences, you should be able to find out all the substring using recursion. Okay, so this is the simple logic of finding out all the subsequences. Now how can I find the base condition? Okay, so base condition, I cannot directly think about base condition without writing down the recursion, right? So first of all, I'll give you an idea about the recursive algorithm that we will be using over here. So algorithm for recursion, the same diagram that I have used over here, I will be converting it into recursive code. Okay, so this is my function. It will take two strings S1 and S2, and the length of the string S1 is n m. Okay, fine. Here I will write down the base condition. Okay, fine. After that, I will check the last character. If the last character of S1, what is the last character? S1 of n minus 1 is equivalent to what? S2 of m minus 1. If the last character is matching, then what should I do? Just think about this thing. I will discard the last character, basically including the last character, and now I will make a function call for n minus 1 and m minus 1 length of S1 and S2. And the other recursive call will be this one. Now I have written an AND over here, right? Basically, I have to find out the answer that how many subsequences are matching for this subproblem and how many subsequences are matching for this subproblem. And I will add this because I need to find out the total count. Okay, fine. So what I will do, I'll make a function call over here. So I'll make a function call. I will discard both the last character because they are matching. So S1, S2, discard the last character. Okay. And do the addition. I will add addition over here. And now a recursive call, I will discard only the last character of S1. Okay, so now S1, S2, discarding the last character of S1. Although it is matching, I am finding out all the subsequence. Now I will keep S2 as it is. Okay, fine. So this is what I will be getting as an answer if the last character is matching. And this will be returning some integer value. And my target is to return the integer value over here. So I'll add a return statement. Okay. So if the last character is matching, the logic has been written in this manner inside our recursion. Now, if the last character is not matching, this will be our else part. So try to think what will be the recursive function. Okay. So let's see if the last character is not matching. So what I will do, I'll make a recursive call fun of S1, S2. I will discard the last character of S1 because it is not matching, and I will keep the string S2 as it is. Okay, fine. And I will add a return statement. So that's it. This is our logic of recursion. Pretty simple. Okay. Now what about the base condition? So what can you say about strings of length 0 when S1 is 0 and M1 is 0? So there are three possibilities over here. Let's say N basically is equivalent to 0 and let's say M is not equal to 0. Now I have to find out the subsequences. Okay, I have to match the characters of S2 inside N, inside S1. This is S1, this is S2. But I can see I have exhausted S1. So what should be the answer? So answer will be, let's say, can you find any subsequences? No, I cannot find any subsequences. Now let's say if n is not equal to 0 and let's say m equals to 0. So what does this indicate? This indicates that all the characters of S2 have been matched with what? All the characters of S1. So we have found one subsequence. So this says, yes, you have found an answer. Now what can be the other possibility? The other possibility is, let's say both the substrings have been exhausted. Okay, fine. So what does it mean? It means that we have found a sequence, then and only then your m will be 0. Because in the recursion you can see you are decreasing the value of m. So what does it mean? You have found a subsequence, yes. Okay, fine. So what I will do, this recursion will return an integer value. It will return either 1 or 0, like basically. So this will be returning 0. So can I write this entire thing as, let's say if my m equals to 0, that means I have found a subsequence. It does not matter whether S1 has been exhausted or not. I will simply return what? 1 over here. And now let's say if your m is not 0 but n is 0. So that means you have not found any subsequence that is matching. Some characters of S2 are yet to be matched, right? So I will be returning 0 over here. And this is our base condition. So you yourself will be able to write down this kind of recursion if you are good at so-called like recursive problems. And this is one of the basic pattern of recursion. When you have studied recursion, you have solved these questions on how to find the subsequences and how to find the substrings, how to find the subarrays, all the subarrays. So that is with little bit modification of that over here. Okay. So I'll give a dry run of it right now. Okay. So I'll take the same example that we have seen over. What was the example? So this was the example. Now, so let's have a dry run of this example. Okay. So I have this example S1 equals to this and S2 equals to this. So my target is to match the last character. Okay. So what can you say about the last character? They are matching? Yes, they are matching. I'll say they are matching. So what I can do over here, if the last characters are matching, I have two possibilities. I can discard the last character of S1 and think about this much of string, and I can find out how many subsequences are there that match the entire string S2. Or what can I do? I can match this character and I can solve this other subproblem. So I will have two subproblems like this, that is S1. I will discard the last character, let's say. Okay, so this is my sub problem. Now I have to solve this sub problem. And what is the other thing that I can do? And basically the addition of that recursion. And my S1, I will discard only the last character of S1 because I want to check whether in this subsequence, in this substring of S1, how many subsequence matching S2. And now I will have S2 and this is AB. Okay, so this is a problem, this is a problem. So let's try to solve one of the sub problems so you guys can get an idea. So I'll solve this sub problem. So here it goes in this manner. So I have my S1 A C A B and my S2 is what? It is A. Okay, so matching the last character. This is the last character. Do they match? No, they are not matching. If they are not matching, then what can I say about the recursive call? So I have my S1 and this is not matching. So I have my S1. So basically I need to discard this character, right? Because it is not making sense if I include it, right? So I will have my entire string S1 as ACA, and what is my S2? It still is A. Okay, fine. Now again this problem is the last character. Do they match? Yes, they are matching. They are matching. So the last character is matching, right? Over here the last character is matching, right? Now what can I say about this last character if they are matching? I have two possibilities, right? I can discard this and I can think about the other substring. So now I have two problems over here, S1 AC, S2 A as it is. And what can I do over here? S1 AC and S2 empty. So what I did over here, basically I saw both the characters are matching. If both the characters are matching, I can either match the character. So I have matched both the characters. So now my S1 will be this and S2 is empty. Else what I can do, I can just think about this string and I can think about this much of part. So this is the other recursion, right? So here here it is completely visible that you have matched all the characters of S2. So that means you have found a subsequence. So if you found a subsequence, what should you do? You should return one subsequence has been found, right? And over here still it is not, S2 still has some characters to be matched, right? So what can I do over here? So over here this is my another problem, right? So for this problem what should I do? For this problem I'll try to match the last characters. They match? No, they are not matching. They are not matching. If they are not matching, then basically what does it mean? I need to discard this and I will be thinking about this string and this string. So I'll make a recursive call over here, S1. Now what do I have? S1 is equal to A and S2 is equivalent to A. Okay, fine. Now here what can I say about the last characters? These are the last characters and they are matching. If they are matching, then what should I do over here? Okay, so that means two possibilities. I can either discard this and I can think about the rest of the string of S1 and I can find out whether I find the substring that is matching S2 or not, right? Or I can discard both the characters. So let's say the possibilities will be, I can discard both the characters, so my S1 and S2 will be empty, right? And if I discard the character A of S1, so S1 will be empty and S2 will be what? It will be still containing A. Now what can you say about this part? S1 has been exhausted, now S2 has still one character to be matched, right? So not found. No subsequence can be found now. So what should you return? The answer will be 0. In this I cannot find any subsequence. Okay, and here I have found a subsequence because S1 is empty, S2 is empty, right? So I will be returning a 1 over here. Okay, fine. So this function basically over here, basically the values will be added, right? So 1 plus 0 will be what? 1. So this function basically will be returning what? It will be returning 1 to the parent function. So 1 will be returned over here. So this will be 1 and over here this is already 1. So adding both these values, right? Because it was matching. The problem was of matching. Okay. Now 1 plus 1 will be 2. So this function will be returning 2 over here. Okay. So this function basically was called from here. So over here at the end it will reach over here. So I'll be getting 2 in this manner. So for this sub problem I have got the answer as 2. I have found two subsequences that are matching as 2. Okay, now I have to solve the same manner for this also, and I will add both these values and I'll get the answer for the entire subproblem. So this is the dry run of our recursion, and it's better that you do once the dry run of this entire problem and to get a basically to get a clear understanding, right? Okay, so I'll be implementing this part and let's try to see how the implementation goes. So over here I will create a function in order to implement. So public void fun string s1 string s2 integer n integer m. Okay, fine. So we know the base condition. So this is the base condition. So if my m has been exhausted, then that means I have found a subsequence. Okay, fine. Now, if m is not 0 and n equals to 0, then what does it mean? It means now you cannot find, okay, you cannot find any subsequence because you don't have any characters inside S1. Now, the possibilities. If the last character matches, so if S1 dot character at n minus 1 equals to S2 dot character at m minus 1. If they match, then I will make two recursive call. I'll pass S1, S2, and then I will discard both the last characters because they are matching, or I can discard only the last character of S1. So fun S1, S2, and I will say n minus 1. I'll keep S2 as it is, and I'll return this value. Else, if the last character does not match, okay, so I will just basically return what I will discard the last character of S1, and in this manner. Now let's make a recursive call to this function from here S1, S2, and let's say S1 dot length, and let's create this variables over here. Let's define these variables. Integer n equals to S1 dot length, and integer m equals to S2 dot length. Okay, and this is S1 and S2. Okay, whatever value is written by this function, I'll return it. Okay, and now let's say to compile and run. So we got, okay, it is void. I need to change it to integer. Okay, so it is working perfectly fine, but think about whether this will get submitted or not. Obviously, it is a brute force approach. You are trying to find out all the subsequences of S1, right? So think about the time complexity. What will be the time complexity if you are trying to find out all the subsequences of S1? So if you are trying to find out all the subsequences of S1 and the size of S1 is n, so that means what you are doing over here, you are either including a character or you are basically including a character or excluding a character, right? So there will be ith character, basically you will be including or you will be excluding. So how many characters are there? There are n characters, and there are two things that you can do for each and every character. So what will be the time complexity? It will be order of 2 to the power n. And what is n? N is the length of the string S1. And what is the space complexity over here? Order of what? Order of 1 if you ignore the recursive stack. So this becomes your time and space complexity. Okay. And obviously it will not get accepted because it is exponential time complexity, right? Now what can I do over here? In order to optimize this, what can I think about? So if you pay proper attention, you are trying to solve some of the problems repeatedly. See over here. If you observe inside this S1 and S2, you are trying to find out all the subsequences, right? So it is possible that you will encounter the same problem quite a times, and if you try to save the answer of that problem for some S1 and for some S2, if you try to set the answer somewhere, basically create a dynamic programming table, DP table, and then store it, then it will be very much convenient. I can directly fetch the answer from there. So that will basically help me to optimize the results, right? So now we need an optimal approach. So what I will do, I'll try to memoize this. I will try to memoize this. Okay. So I need a DP table. I'll be needing an integer table. So the size of it will be what? N plus 1 plus m plus 1. Why? Basically, DP of what? DP of I comma j. Basically, it stores the answer for some function for S1, S2, I comma j. Okay. So the initial problem is what? Function of S1, S2, n and m. So I need DP of what? DP of n comma m is required for that. These are the indexes, n index, m index. So I need the size to be what? N plus 1 and m plus 1. That is how I thought about the sizes. And how to think about what are the dimensions of this dynamic programming table, of this DP table. Have a look at what values are changing. So n and m are the values that are changing inside your recursion. So that indicates what will be the dimensions of a dynamic programming table. Okay, so I'll try to memoize it. Very simple memoization is required, right? So wherever you are trying to find the answer, first of all, let's create a DP array. Okay, so integer DP. I will initialize this over here. I'll declare it over here. Okay, and after finding n and m, I will say DP equals to new integer n plus 1 and m plus 1. Okay, fine. Now here DP of what? N comma m is this, and here DP of what? N comma m is this. Memoized solution, right? Pretty simple. And one thing that I need to find, let's say if answer for n comma m is found. So let's say if DP of n comma m is not equal to minus 1. So I need to initialize with minus 1, right? Because some values needs to be initialized. So 0 can be the answer. So I will be choosing -1 as the initialization value of d. I forgot to initialize, so I'll add initialization over here. I equals to 0, I is less than or equal to n, I plus plus, and integer j equals to 0, j plus plus, and dp of I comma j equals to what? -1. Okay, fine. So I'll basically, if I find that dp of n comma m has been found, so I'll be returning that value dp of n comma m. I will not make any kind of recursive call. Okay. Now let's try to compile run. So this is our memoized solution. Okay, working perfectly fine, and let's try to submit it. And now try to think about the time complexity over here. Okay, fine. We are getting an answer that is wrong answer. So what did we miss over here? We missed the last point, that is, since the answer can be very large, return modulo 10 to the power 9 plus 7. So let's do that change over here. So integer mod equals to 10 to the power 9 plus 7. So I'll apply mod over here. Whenever I do the addition, I'll apply the mod on the result. So I'll say modulo mod. Okay. And yeah, anywhere else? No. So now let's try to submit it. Okay. So now try to think about the time complexity in this. So what do you think is the time complexity? So we need to have a look at the DP array that we have used over here. What are the dimensions of this array? It is n plus 1 and m plus 1. So that means we have a DP array of size n plus 1, over here n plus 1, and here we have m plus 1. And here none of the cell will be visited twice. All the cells are going to be filled only once because of the condition that we have used. So that means, what is the dimension of the DP array? N into m cells are present. So the overall time complexity now comes out to be n into m. And this is our space complexity, will be also n into m, because we have used a DP array. So this is the time complexity. Order of 2 to the power n was our brute force approach. Now it is n into m. Pretty good time complexity, right? So this is our memoized solution, and here we are using recursion. Now let's say in the interview they will say that I want the tabulation approach. I want the top-down approach, not the bottom-up approach. Okay, so there's a technique to convert the recursive memoized solution into what? Into tabulation. It's very easy. Okay, so let's see the most optimal solution. So here also we'll be using the DP array n plus 1 and m plus 1. But I will not be using any kind of recursion, right? So I will be converting this recursion. I will be converting this recursion into what? Into our into our tabulation approach, into our top-down approach. Okay, so it's very easy. So first of all, have a look at the base condition. This will be the initialization for our dynamic programming table. So base condition is saying that when m equals to 0, that means when your column m equals to 0 over here, all the values will be 1. So that means it is saying that when you have s2 that is empty, when you have s1 equals to ab, something like this, which is non-empty or empty, at that time it says you have found one subsequence. It says you have found one subsequence. But in the question, if you have a look at the size of s1 and s2, it is always greater than or equal to 1. Always it is greater than or equal to 1. So you will not find this kind of test case, okay, when the checking of your code is done at the backend. Okay, so but then also this initialization step is required because we will be calculating different values, and that values might require some of the values from 0th column. Okay, so what I will do, and when n equals to 0, that means the first row is 0, then it says if you don't have any string s1 and if you have s2, whether it is, let's say, non-empty, then that means you don't have any subsequence. Then the count of subsequence will be 0. So over here, I have drawn the table for this problem that we were talking about, right? So here is our character. So this row indicates S1. So all the characters are indicated over here. A, C, A, B and B. And this is what for S2, that is A and B. It represents the characters over here. Okay, so the initialization step that I was talking about. So the base condition, what was the base condition? It was saying that when m equals to 0, so this indicates m, length of s2, and this indicates length of s1 n. So it was saying when m equals to 0, you have at least found one subsequence. So all the values, I will initialize this as 1. And it was saying that if you don't have any characters inside the string s1 and you have some characters inside s2, that means you will not be able to find or match any characters of s1 because you have s1 that is having length empty, 0 length. So for that the values will be what? 0. So this is the initialization step. This the base condition that have been written over here. Okay. So two for loops will be used. for, let's say, 0th row. Okay, so for I equals to 0 to what, I is less than or equal to m. So I will say dp of what, I will be what, 0, means the row number will be 0 and this will keep on changing. This will be what, 0. Now let's say for the 0th column the values will be 1. So for I equals to 0 to I is less than or equal to n. Okay, so I'll write down over here. So dp of I comma 0, that will be equivalent to 1. So this is the initialization for the 0th column and this is for 0th row. Okay, fine. So I have converted the base condition. The entire base condition has been converted into so-called, this is our base condition. Now I need to convert this logic. Now converting this logic is pretty simple. So wherever you have the value n, just convert it into I, and wherever you have the value I, m, convert it into j. That's pretty simple. Now from where we will start the filling of this? We will start the filling from this, that is 1 comma 1. So I'll add the conversion over here. So I'll copy this code, this part, okay, and see the check that I have used over here. dp of n comma m is not equal to -1, so I'll return dp of n comma m. So this is required when we use recursion. In tabulation we are not using recursion, so this condition is not required because this is top down approach. Okay, now this part will be converted into so-called tabulation. So how to do that? Let's see. So I'll copy this code over here. Now starting the filling of the cell from I equals to what, 1 and 2, I is less than or equal to n. For j equals to 1 to what, j is less than or equal to m. Now wherever you see n and m, convert the n into I, convert m into m into j, and this function will be converted into dp. Okay, so what I will do, if I will write down, if s1 of I minus 1 equals to s2 of j minus 1, then what does it mean? It means that dp of I comma j is equivalent to dp of I minus 1 j minus 1. Have a look at this code simultaneously. Plus, I will add plus what? Plus dp of I minus 1 and j. Okay, if the character ith character matches in both of them. Else, what, dp of I comma j is equivalent to what, dp of I minus 1 and j. I've converted this into entire tabulation, and now here ends our for loop. So you will be confused that what is the logical explanation of it. You might have a doubt in your mind that what is the logical explanation of it. So I'll give you a logical explanation of it as well. But I hope this part is clear to everyone. How we have converted the memoized solution into tabulation. So we have done the conversion. So entire recursion has been converted into tabulation in this manner. Now here, first of all, I'll give the implementation, or let's say first of all, let's do the dry run of it. Okay. So now let's do the dry run. So what does it mean? So first of all, dp of I comma j, the definition, what does it mean by dp of I comma j? Let's say over here you have some value, then what does it mean? It means that it indicates the count of all subsequences of s1 in which the length of s1 will be what, I. Length of s1 will be what, s1 will be having length I. Length equals to I, that matches s2, and the length of s2 is what, is equivalent to j. dp of I comma j indicates that. Okay, fine. So now I will take this logic and I will apply it over here. So I'll take this things over here, let's copy it. If the character is matching, then what should be done? Okay, so I've indicated the characters over here. I've indicated the characters over here. S1 is this, S2 is this. Okay, I'll write down that as well. This is what, S1, and this is what, S2. Now dp of 1 comma 1. So what does it say? Check the character. They are matching. Then what should I do? So dp of 1 comma 1 is equivalent to dp of 1 0 comma 0 plus dp of what, 0 comma 1. So what does it say? For this value, if the character is matching, fetch the value diagonally, this value, and fetch the value over here. Add both these values, I'll be getting 1. So that is what I will be placing over here, 1. Okay. Now for this cell, dp of 1 comma 2, dp of 1 comma 2. So here the character is a and this is what, b. Okay, so they are not matching. So if they are not matching, then the previous value will be fetched over here. So this says dp of what? 0 comma 2. So 0 comma 2 is what? Over here I can see it is 0. Okay. So moving forward over here. So this character is matching C and A. No, it is not matching. So this above value will be fetched over here. Yes. Now here for this C and B are not matching. So above value will be fetched over here. Yes. So 0 will be placed over. Okay. So now moving on forward. So we found the answer for dp of 2 comma 1. It was what? dp of 1 comma 1, right? And dp of 2 comma 2 we found using this formula, using this observation, as what? dp of 1 comma 2. Now say, let's say dp of this, dp of 3 comma 1. So what are the characters? Are they matching? This a and this a? Yes, they are matching. So it says diagonal value, right? So dp of 2 comma 1 according to this formula, try to find the values over here, plus dp of what? 2 comma 1. So this is 2 comma 0, sorry. This is dp of 2 comma 0, dp of I minus 1, j minus 1, 3 minus 1, 1 minus 1, and dp of 1 minus 1, that is, I mean dp of 3 minus 1 and j as it is. So this value added with this value, so I'll get 2 over here. Okay, and if you keep on filling this value, at the end you will get your answer over here. Okay, so this says the number of subsequences dp of n comma m. It says count of all the subsequences of s1 with length equals to 5 that matches s2 of length equals to 2. The entire sub problem, that answer will be present over here. Okay, I hope you got an idea. You can do the dry running and you can try to fill the rest of the values and try to find out the value. Okay, so now let's try to see the implementation of it. I'll try to code this. Let's see. So I'll create a new function over here. So public, I'll say int, and I'll say tabulation string s1 string s2 integer n integer m. Okay, so now initialization step. Okay, so initialization step. So I'll say, first of all, I'll fill the 0th row. So for integer j equals to 0, j is less than or equal to what? M, and j plus plus dp of 0th row. So that means row number will be 0 is equivalent to what? It is equivalent to 0. Now for the 0th column, for that I will iterate over I equals to 0, I is less than or equal to n, and I plus plus. Okay, and dp of the row number is what? Row number will change, the column number will be 0, the value is equal to 1. So don't interchange these values, okay, because 0 comma 0 will change over here. If you interchange, if you initialize 0th row first, if you initialize 0th column first and then 0th row, the value of cell 0 comma 0 will change, it will become 0. So now the logic, for integer I equals to 1, I is less than or equal to n, I plus plus. For integer j equals to 1, j is less than or equal to m, and j plus plus. Now let's say if s1 dot character at I minus 1 is equivalent to s2 dot character at j minus 1. If they are matching, then what? dp of I comma j will be what? dp of I minus 1 and j minus 1 plus dp of I minus 1 and j. Else dp of I minus 1, that means the characters are not matching, equals to dp of I minus 1 and j. Now I'll not forget to apply the modulo over here, right? The mistake that we did earlier. And that's it. And here I will return the value of the cell dp of n comma m. Okay, now this tabulation will be used. So I will remove this initialization part that I have done over here, and I will call tabulation instead of that. So now let's try to submit this and let's try to see. And we can see that the problem has been successfully submitted. So this was the top down approach for our question, that is string subsequence. And if you look at the time and space complexity, the time complexity will be order of n into m, and the space basically order of n into m because of the dp array, but we have not used any recursion. Okay, so that was it for in this video. I hope you understood everything about the tabulation and memoization and how we basically converted the memoized solution into tabulation. So do hit the like button if you really enjoyed the solution, and do comment down your approach of this problem. So that was it for in this video. I will be seeing you in the next video. Thank you for watching.